morning, and welcome back to day 2 of this technology transition workshop here at NFSTC. And the first item on the agenda this morning is a summary of the results from the demonstrations and the sample analysis trials that we had yesterday. And one of the things I asked each of you to do was to kind of summarize your experience and the results that were obtained yesterday afternoon. So I'd like to go around the room and have a representative from each of the groups make a very brief presentation. And what I'd like for you to do is to just give us your feedback on the analysis you had. So I know that we had a couple of issues with some instrumentation. We'll go through that, and that will help us to improve the exercises in the future. So why don't we start with Tom Sharkey as the first team, Brian and Tom. You want to summarize the results?
Sure. We started out basically by doing a EC, which was abbreviated for, and I can't remember the name.
Ethyl centralized?
Yes, sir. Thank you. We decided to do that on a static testing. We used a mobile trace. The EC was 100 parts per million. We let it permeate for 15 minutes in a can before we tried testing it. Again, after the 15 minutes were up, we went to use the mobile trace, and the actual machine was actually recalibrating or at the time. So we actually had to stand for an extra minute with the sample out in midair in hand. And by the time we got the sample in the mobile trace, we didn't really get a reading. So we think the EC pretty much evaporated while we were waiting for that. So we decided then after that to do the TNT sample. Again, we did that static. The TNT was 240 parts per million. 15 minutes permanent in the can. We used the itemizing on that, which worked very well. Let's see, the time was 6.070 with a reading of a peak of 2010. And after that, we did the blank on the mobile with the mobile trace and a dynamic mode inside a can, and again that worked well. We had no reading as expected on that. Then we used the red dot black powder. We did that on a static. The red dot was 100 milligrams. Is it milligrams, MG?
Milligrams.
Thank you. We used the mobile trace on that. The time was 3.829, and we peaked out at 6231 on that. That was pretty good reading on that.
Now you were inside the can. I noticed when you were doing your sample, you actually put the head of the thing. So it's not really necessary to do that. In fact, one of the things you might want to do in some future trials, just to try it out, bring it away from the mouth of the can.
So we don't overload it, basically.
Yeah, I mean that's what you did when you put it inside the can. You will overload the instrument. So bring it out. If you're at 0 centimeters, right at the mouth, you're gonna get a huge signal. So we've done it as far away as 3 to 5 feet from the mouth of the can, inside of a big container like an LD3, and we still get a reading. So putting it inside the can actually will overload the instrument.
Now, is the black powder pretty volatile? I mean, is it?
Well, some of the components are 2,4-DNT. So one of the things that we talked about yesterday was the volatile components of black powder. Black powder itself is not volatile. It's inorganic, potassium nitrate and other inorganics. But there's 2,4-DNT, which is extremely volatile. So you'll get, that's the most prevalent hit that I think each of you got with this particular black powder or smokeless powder. There's ethyl centralite, which is also volatile, and diphenylamine. So all of those three are programmed in the instruments. And Patty Diaz is actually going to address the ethyl centralite issue. We're actually going to wait until all the other, because I think maybe your team was not the only one with ethyl centralite issue. So we'll talk about that later. Okay, so the blanks came out well. The solid 100 milligrams, which is 1/10 of a gram of black powder, you had overloaded the instrument with a lot of signal, and then the TNT, 240 parts per million, which is also a very small amount, also gave you a good signal. Any other observations?
No, we did do one more. We did the H322. Is that what it was? I can't read it.
Yeah, that's another smokeless powder.
We did that dynamic. Did that also in the itomizer also. Results were, time was 5.603 with a peak of 1683. Worked well, and that was at 100 milligrams.
And that was
That was dynamic, and that was outside. Yeah.
And that was dinitrotoluene, DNT.
Yes. Yes, sir.
Okay, so with the exception of ethyl centralite, everything else was as expected.
Correct.
Okay, great. Thank you. Who would like to go next? Adam?
Okay. Well, we began by blanking each of our sample cards just to make sure they were cleaned out and clear before we start anything else. Then we established Then we established a control blank by putting it into the empty can for 15 minutes, and allowed that one to start cooking. And then we added 10 microliters of the liquid sample. Unfortunately, we failed to capture the name of the liquid sample, but I do remember it was 2 parts, and one part of it had AC. Help me out with that.
Acetonitrile? Acetonitrile solvent is the solvent, and the majority was either TNT.
It was TNT.
TNT.
Yeah, that's the one. I apologize for that. I missed that. In any case, we put that in the can with the preparation for 15 minutes to let it start cooking. And once they were underway, we supervised the other team do some calibration and validation on the mobile trace so that we knew that it was prepared for work, and then we knew we were not going to have to repeat that. Then we ran our liquid spiked sample in static form through the itomizer, and we detected nitro 3.838 seconds with a height of 4021. Then we ran the blank card that was in the blank can and on the mobile trace, and there was no material detected, which was expected. Then we ran our dynamic 30-second sample on the red dot using the mobile trace, and we found nitro at 3.829 seconds and a height of 4595. And then finally we ran the 322 static sample in the itomizer, showing DNT at 5.603 milliseconds and a height of 5537. Interestingly, though, we did try to run that through twice on the mobile trace, but both times it showed it was clear. So we actually ran it through there twice, and then we took it over to the itomizer, and it did come up with the reading. So some of that material did volatilize off, but and we found later that that mobile trace instrument needed a little service. So.
Mm-hmm. Yep. Okay. We'll also cover that in a couple minutes with Dr. Diaz's comments. Any other observations or no? Is this the first time you've ever run one of these IMS instruments?
No, we use some Sabre 4000.
Sabre 4000.
So
okay.
familiar with it. These particular machines, no, I've not seen
Okay.
these ones before.
Okay. How many people have never, before yesterday, operated an IMS instrument? Raise your hand. Everybody else has had some experience with them. Okay, great. All right, Robert, do you want to go next?
Okay, like I said, I've never used that equipment before, but it caught on pretty quick. It's pretty easy to use. So we ran the red dot dynamic on that through the itomizer. I picked up a nitro and DNT. On our static, we did the liquid DNT at 100 parts per million through the itomizer again, and again picked up on DNT. We did the H322 in the static, ran it through the mobile trace. We got a hit on our compound of DNT, and we did a dynamic on the blank and came back nothing on that. We didn't have any trouble at all running our samples. The only thing we did see is clearing the piece PMEs a little bit. Took a long time sometimes. I don't know if we got too much sample on there, and it just took a while to clear it. But that was the only trouble we had, is trying to get those things clear to reuse them.
Great, great. Wonderful. We'll have Dr. Diaz come up and say a few words now about both the EC and the mobile trace issues we had yesterday. But what I want to say is one of the aims for the exercise was to get you to not be afraid of using the instruments, get you acclimated, because today we're going to be using them much more in the later this morning and in the afternoon for both particle sampling and also some volatile sampling when we get to the warehouse on the vehicles. We got a couple of vehicles out there, and I think that's when we're going to have some fun. So, Patty, you want to say a few words?
Mr. Sharkey, as far as the ethyl what we were depositing within the can was a very small amount of the compound, which is very volatile, and the mass equates to about 1 microgram. So it's a very tiny amount that we're trying to sample from to begin with. So we sampled that for 15 minutes. So we would have absorbed the ethyl compound on our PSPME device. But because there was an issue with the timing of another team doing a calibration or a verification, there was a window of like about a minute where, because we were already absorbing such a small amount to begin with from the source, then that time lapse in between, probably the ethyl volatilized off of the PSPME device. Now, if we had had a larger amount to begin with, and in a normal pipe bomb setting, you would have a couple pounds of the smokeless powder anyway, you would have had more available EC to sample from. So we were pushing the limits. We wanted to show you the sensitivity or the capability of the PSPME device, but unfortunately with the timing, we weren't able to get it into the instrument in time. But it does work, the ethyl centralite being detected in this form by PSPME IMS. Now, as far as the instrument issues that we had with the mobile trace, it did need service at that time. So afterwards that you noticed the 2 times that you ran it and you didn't see anything, we did do some maintenance to the instrument, and afterwards we were able to calibrate it and verify that everything was okay. But it goes to show that the PSPME device absorbed so much of your TNT that it was desorbed twice, and then you went and took it to the atomizer and you did still see an appreciable signal. So in a small amount of time of 15 minutes of extracting a small amount, which was 240 ppm, which equated to 2.4 micrograms, you were able to absorb with the PSPME device a sufficient amount. So those are the comments that I had on the 2 issues that you experienced with. But I'm glad that it seemed like overall you had a good experience with these experiments, and now you'll be able to apply what you learned yesterday into today's particle sampling exercise and the vehicle sampling exercise, which should be both fun and interesting for you guys to try out. Do you have any other questions?
Just for the benefit of knowing, if a responder were to go out and sample with a PSPME, and we're bringing them back, maybe in a container out of a hot zone into an area where we would sample, what do you think that the PSPME will hold it for, let's say, the time it would take us to get back through, maybe even a decon, maybe 20 minutes?
We've done experiments, and we do find that it does, for certain compounds, it does hold it enough, 15 to 20 minutes, and that is without a cover on it. But the final configuration of this PSPME device will have itself a holder to make it more flexible to use the device without having to use tweezers, and then it will have a cap, so once you come out of the hot zone, the analytes will be contained within the PSPME device. You would remove that cap once it's time to desorb it, so you should not have that issue. And on top of that, I also referred to, in a real case scenario, you would have much larger amounts of the threat agent available to absorb your volatile compounds from. And again, this was just, we wanted to push the limits and show you how sensitive it was. That's why it didn't work out. Thank you. Any other questions? Okay. Thank you very much.